And like I always say, please, please, please ask questions. A lot has changed. It's not, a million things, but probably a good 100 things have changed. So it'd be good to be able to ask, like, hey, Ryan, like, how's this going to work? Or I have this weird problem. What can I do about it? Or just things in general. Go ahead and ask. But otherwise, I'll get started, and we'll talk about some TensorFlow 2.0, all the changes that have happened, and also what you need to do to be able to get it to run on cloud and all other fun stuff. All right? So, in case you haven't heard, which I think you have if you've come to this talk, is TensorFlow 1.x is now been moved to 2.0. The last release of TensorFlow was 14, so 1.14. And then we're going to 2.0 now. In the ASL, where many of you have been taught, we have been teaching, when I first started teaching way back over 2 years ago, it was 1.2 we were teaching, and now we're on 2.0. So we've made a lot of changes. We've updated the curriculum and everything to try to keep track of all these changes. The last thing we kind of like upgraded it for was 13 and 14, but now with 2.0, there's a lot of differences, keras, and all of that that we need to take into account. So it's nothing scary. It's just different, and the idea is to be more simplified, streamlined, so that way you can get to making cool models faster instead of having to go through a bunch of boilerplate and other non-interesting things. So this is a simplified conceptual diagram. Before, this diagram was much, much larger. Now it's pretty simple. So we know that there's like the training and then the inference side of machine learning models, right? And to do inference, usually you do deployment. Okay, so that's why we kind of have like a training and deployment on this graph here. On the training side, basically your data design would be TF data using TF data sets. You won't be using any of that Q runner stuff and any of that like really old school stuff anymore. That's gone. You used to be able to use it because TF data came out in 1.3. You used to be able to use Q runners and all that stuff still, but it's gone now. There's no reason for that. Just use TF data. It's so much better, let me tell you. And then on like the model design side, you have now keras and pre-built estimators. So a lot of that older way of doing things is gone. Custom estimators, you can still use them, but they're not recommended. Now it's use a keras model and then use that, or just use a straight up pre-made estimator like a canned, DNA regressor or whatever, and that'll get you what you need. Of course, you can create your own custom models, and you can create a class and subclass that into the model class, and then you can run it just like you would anything else. Training, it uses distribution strategies, CPUs, GPUs, TPUs if you want to go really fast. That API is all handled, all very nice, very streamlined. Analysis, TensorBoard. TensorBoard's great. I love it. I use TensorBoard for teaching. I use TensorBoard for building production models for customers. I use TensorBoard in research. So basically all the three things I do in my job, I use TensorBoard. It's very nice. You can customize everything. A lot of that stuff's been rolled into like metrics and everything into summary now, so TF summary. So that all ends up into TensorBoard, and you can see everything more. Another cool thing is Save's model. Save's model has been standardized. Finally, standardized. It's great. Now you can use the same Save model format for TF serving, TF-Lite, and also TensorFlow JS if you want to just do it right in the browser. So it's very nice that all of these three can use exactly the same Save model from however you train it, right? Just put it in the Save model format from whether you're training on cloud, on device, whatever, it now all works wherever you want to deploy it. Also TensorFlow Hub and like our AI Hub. Great place to have a model repository. You can have public ones so that anyone can use it, or also you can find anyone else's that you might want to use. And also you can have private repos for models, so that way if you want to have, keep it under lock and key within your own business, then that's fine, and you can share it with whoever you give permissions to. just kind of a high level thing. I'm sure most of you remember from the ASL that like just one of those boxes in the old way was but even bigger than this current graph right now. So it's gotten much smaller, much more simplified and streamlined. The first thing that they really tried doing was an API cleanup. So TensorFlow, it's open sourced back several years ago now, and there's been a lot of contributions and everything over the years, and it kind of got bloated. All right, specifically TF contrib, it's a great thing. I used it a ton. However, there was a lot of abandoned packages. There was, some packages that got much more love than other ones. Some developers, moved on and kind of like left their baby a little bit. So a lot of the popular ones have now been pushed over into core, but then the rest, contrib is gone. So no longer there'll be contrib to do any of that stuff. Also, there was a lot of duplication. I remember making fun of it a lot of times where you would have the same, you want to do something, but there were 3 or more ways to do it. Exactly the same, they'd be exactly the same values that came out, but 3 different function calls. Why? Because someone over here made it, someone over there made something else, and they all got thrown into the same, module or different modules, and then that's where we ended up. So that's all gone now. They've all tried to consolidate, so that way there's only one way to do everything now, so that way there'll be better consistency across different projects and stuff, so that way you'll be able to work faster and be able to share code and stuff better. Also, the idea is about easy model building, right? Like, there's no benefit to anyone to make model building difficult or slow, so the more that we could help streamline all this stuff and let you get results and run your experiments faster, the better. So some of the main highlights is you want to load your data using TF data. Most of us already do that, but now that's the only way to do that. You'll build and train and validate your model using Keras or pre-made estimators. Of course, you can always do TensorFlow in the back end and create, custom model classes. You'll run and debug with eager execution. So I know a lot of you guys are really excited about that. I don't know, I didn't mind graphs, to be honest, but it was difficult to debug. It was difficult because it kind of had to visualize the graph in your head. Maybe because I'm a physicist or something, it's easier, but you had to visualize it and see how these subgraphs are linking together and what's what and what's burned in the graph, what's dynamic, like a placeholder and stuff like that. It was a little more complicated. Now you can do that with execution, eager execution, and then if you want to get the performance, remember the whole reason for graphs is performance, right? Because you can have TF add, TF add, TF add, TF add, TF add, 5 times, and then the optimizer for building the graph would be like, hey, why don't we just do 1 TF add of +5 and done, right? So if you want that, you can use TF function. TF function is a decorator, which we'll get to in that section, that you literally just put it above a function and boom, now it becomes a graph, and everything calling that will also become a graph, and therefore it'll optimize itself without you having to have it always a graph, so you're debugging when it's a graph as well. This, you debug as imperative, like basically calling Python, NumPy kind of stuff, and then when you actually run it in production, then it's all going to be graph mode, okay? Also, you have distribution strategies for distributed training. So you have really big jobs, gigabytes, terabytes, petabytes of data, variables that can't fit on one node. You need to spread the variables, shard them out to multiple devices. Distribution strategies are very nice. These originally came from the estimators, where we had distribution strategies for those. So all sync, all reduce, and all that stuff is now moved here. And lastly, exports to save model. Like I said, it's all one format now, one serialized format, and that way you can use it on any deployment you want. It's very nice. Any questions so far before I kind of dive a little deeper into any of these? Each of these, I must say. Wonderful. All right, so you want to load your data using TF data. So training data, it's going to be read using input pipelines, which are created using TF data. Now, something that's great, even though you have been using TF data, there's a lot of new TF data things that have come out with 2.0. like CSV data sets, as we'll see in a moment. So therefore, you wanted to build your own, like decode CSV and all that kind of stuff. Now it's just one line of code, boom, you have a CSV data set. It's very nice. Feature characteristics, for example, bucketing, feature crosses. These are all in TF feature columns that you can use with Keras using dense features. Wrapper, it's kind of like the input layer we used to have back in TensorFlow. And also it's convenient input from in-memory data. So for instance, like NumPy and everything, it's all supported. Pandas all supported without having to have a specific input function for it, like a NumPy input function, Pandas input function. Now it just works. It works whether it's a data frame, a NumPy array, or a tensor. It just works. So it's really nice, really extensible. You can mix and match data types and all that. It's very nice. I'll show you an example in several slides. Also, so like I said, Keras. So Keras, it's integrated very tightly with the rest of TensorFlow. So you can access your TensorFlow features whenever you want by accessing the backend. So it's basically just like TensorFlow kind of was. It's a set of standard packaged models. So like linear, logistic regression, boosted trees, random forest, all these things are available, and they were implemented using the TensorFlow estimator API if you want. Right. You can also, if you don't want to train something from scratch, you can use, Keras or the estimator or any of the modules in TensorFlow Hub. TensorFlow Hub is really nice. For whatever reason, a lot of people don't end up using it for whatever reason, but it's very, very simple. You just call the module and a whole bunch of, it's an object essentially that gets loaded in. And like BERT even, is a BERT thing, and you can do pre-processing through TensorFlow Hub, the actual BERT training through TensorFlow Hub, vocabularies, all that stuff. So I think it's an underutilized resource. So definitely check that out and see what you can use from there in combination with AI Hub that has trained models. So check it out. Like I said, it's very nice being able to debug with Eager. It's such a pain sometimes. Just getting into graph thinking is one thing, but then also debugging it. Even if you're really good at understanding graphs, like I have become over the years, it still is a pain in the butt to debug. You got print statements here, TF print, all that fun stuff, logging, TF logging, all that fun stuff. Now it's very simple. You just run it like you would any other program, imperatively, and then you can just check things as you go. Like I said, if you want to have fancy performance optimizations, just wrap it in the decorator TF function. Just at TF function at the top, boom, above a function, and that function becomes a graph. So, if you want performance optimizations, remote execution, the ability to serialize, export, deploy, all that stuff, it's very, very nice to be able to use this, just like simple Python, if statements, all that stuff. What happens under the hood, there's something for TF function, there's something called autograph. Oh, geez, I didn't hear you come in. Welcome. There's something called autograph, and autograph essentially will turn all your if statements into like TF cons. It'll turn your while loops and for loops into TF.while loops. It'll do all that for you. There's very few things it will not do. And if it doesn't actually convert one of your Python-esque functions over, then it will give you a logging, and then you can go and manually fix it yourself. But other than that, it's pretty straightforward. Here's an example. So I have some really stupid function here where I add 1 to whatever my input is. So 3 comes in, I add 1 becomes 4. Okay, and you'll notice what I've done up above is all I've done is add this TF function decorator at the top, at TF.function. That's it. And what that will do is whenever that function is called, it will generate a graph. So you'll notice here that I have a scalar. It's a scalar, it's 1, so it has a shape of, parentheses, basically. I have a vector here, so it's going to be a 2 comma shape vector. Then I have a matrix here, so it'll be a 1 by 1, so a 1 comma 1 shape matrix. What's going to happen here is every time I call this, it's going to, when I call it to .add, it will create a new graph. So I have 3 separate graphs. And then depending on how you connect them, you'll have, the 3 subgraphs all connected into one master graph kind of thing, right? So that's all you have to do. Otherwise, without the TF function, it'll just stay in eager mode the whole time, and it'll be just, 1, you'll get 2, 2, and then you'll get 4 for the last one, right? So there's very little to change here, and like I said, whenever you do this, anything that calls that function will also get turned into a graph object as well. So whatever calls f of x here will also become a graph. So that way, any pieces of your code that require graphs to optimize, like all the way down to the bottom, will be able to be handled, and anything that doesn't need to be graphed will just stay non-graph, right? If you don't need any performance, any of that stuff, okay? Any questions on TF function? Nothing scary. It's one line of code and it turns on something from that's not a graph into a graph, and it basically works out of the box. There's very few times when this will not work. All right, wonderful. Oh, I might as well say that. Speaking of which, I'll say it a little later on too, but guess what? Sessions are gone. There are no more sessions. So I know you used to do tf.session and tf.graph and all that stuff, all gone. All gone. It's all handled under the hood now. You know, whether if you have a graph, if you don't have a graph, you don't even need a session because there's no graph to run. So therefore, you don't even have to have any session at all under the hood for some subcomponents. But it's all handled for you. So for those of you who hated sessions and, you know, feed dictionaries and all that stuff and fetches and stuff, it's all gone. So hopefully those out there are like cheering right now. Yes, wonderful. And whoever loves sessions, I guess just stay in 1.x and, you know, stay in Stone Age. But, you know, the world keeps turning. Next is distribution strategies. Okay, so for very large ML training tasks, so large models and or large data sets that need to be distributed, you know, perhaps. The distribution strategy API, you know, these are all links. I'll post the slides, of course, to the repo, so that way you can click all these things and figure out how to use it for your own uses. It works great for CPUs, GPUs, TPUs. You can enable training workloads to be distributed to single node stuff or multi-accelerator things, you know, multi-node, multi-accelerator configurations, pretty much whatever you can think of. You know, having one TPU, having tons of TPUs, having some hybrid TPU, CPU craziness going on, you can do all that stuff, all right? Even though the API, you know, it supports a lot of cluster configurations, there are templates to deploy training on Kubernetes clusters if you want to do on-prem or cloud environments, you know, are provided. So there are some really crazy stuff if you want to. A project I just finished, actually, we used Kubernetes, a cluster to actually host our model, not for training, but for inference, because we needed very specialized things that it had to be basically real time. So we ended up using Kubernetes and hosted our model on it. So it's really cool. So it's not like you can't find a solution, it's just figuring out what works best for you, right? But pretty much everything out of the box, 99% of stuff, or 0.9 I would say even, you can just use the distribution strategy API and it just works. For the 0.1% left, Kubernetes basically solves the rest. It's really nice. Lastly, like I said before, you know, it's great. You get one standardized saved model. I love standardization. I don't think there should ever be like two ways to do something that are equally performant and everything. Just wrap it all into one thing. So now serving light in TensorFlow JS and Hub, everything else is all using the same exact save model serialized format. So therefore you can mix and match, you know, whatever you want to use, you know, train the exact same thing, you know, on cloud, you know, and serve on cloud, and then you say, hey, I want to put it on smartphones now, and then just boom, same exact save model. You do not need to retrain again. Just literally call that save model using TensorFlow Lite on the smartphone, and boom, works. Or in the browser for .js. It's just very nice. You know, I should have done it a long time ago, I'd say, but you know, better late than never. So really happy that this is here. So another cool thing they added is TensorFlow data sets. So we all know what is the biggest part of machine learning. It's not necessarily the models, it's the data, right? It's, you know, finding data sets, cleaning data sets, pre-processing, you know, getting it in the right shapes and all that stuff. That is the brunt of ML, right? It's 80, 90 something % of ML, okay? And one of the annoying things is finding them, right? What's a good data set for something you want to use, right? Maybe you have a small amount of data, you need to augment it with something big. And you want to easily find it without having to go on Google and searching all these repositories and everything. Wouldn't it be great if you just had like a one-liner? Well, you do. with the new tf.data.datasets. Okay, it's really nice. There's a guide here. There's a list of data sets you can go to. There's like 100 something there that when I last looked. I guarantee they'll be adding more and more as time goes on. There's audio ones, image ones, structured data ones, summarization, text, translation, and video data sets. So covers a large gamut of things that you might want to use. They're very nice. It's very simple. Here's an example. So all you do is import, the library basically. You load your data set. For instance, this is MNIST. You can say how you want to split it, how you want to do like labels, all this kind of stuff. There's a whole bunch of parameters for that method there. And then you just throw it in your data set like normal. Shuffle, batch, prefetch, whatever. Do a take. Take is where we're only taking so many examples at a time. All that stuff you can do. Very, very simple. You see it's one line of code, .load. And it works. It's very nice. So yeah, so if you ever want to just use something really quick and like use it as a prototype, oftentimes when I build models, I use fake data to build the model. A lot of the webinars I've actually given, a lot of those models started off with just fake data. Either I made it up or I pull an MNIST or something, build the thing, and then once I get it working more or less, then I throw the data set out and bring the real data in and see how it does. Of course, there'll be some fine tuning and all that, but more or less, it works out of the box, right? Like anomaly detection started with me just using some simple sine waves and everything. And then I put real like IoT data in there and it basically worked. There's very little to change except hyperparameters, which is obvious, but it was pretty nice. Any questions on any of that before we get to the more like that's like the features, and now like here's how do I get my stuff to actually work now using those features. Any questions before we like change gears there? Those are the main changes. Nothing? Be shy. It's always like I'm just waiting for someone to raise their hand like I have a question. All right. So that's cool. How do I use all this cool stuff that I just talked about? Well, you need to convert your 1.x code to 2.0 code. Okay? Better if you're doing it sooner than later, just like you should be doing sooner than later for moving from Python 2 to Python 3. Like, I hope you're not surprised, but in less than 2 months, it will be not supported anymore for Python 2. So please go to 3. I don't know why anyone uses 2 anymore, but use 3, please. And also use 2.0 because there's so many more cool things. And 1.x is not going to keep growing. It's done now, and 2.0 is going to be something that keeps going on and on while the new stuff gets added. So please start using 2. How to move to it? It's very simple. It's a 5-step process. Number 1, run the upgrade script. Like they couldn't have made it any easier. They made a script where it will go and parse your code and it will turn it into 2.0 basically. It'll work 99% of the time. For those times it doesn't, move on to step 2. Move on to step 2. It's basically remove any contrib symbols. So any contrib stuff you have in there that didn't get converted, just figure out non-contrib ways to do your stuff now. Okay, you want to switch your models to be object-oriented style. So using Keras, using model classes, subclassing the base model class from Keras instead of doing any custom stuff. You want to use tf.keras or tf.estimator for training evaluation loops wherever you can. No more like crazy while loops with variables and any of that stuff. Just use Keras layers and stuff. It's really nice. Like don't use any of that crazy stuff. Otherwise, you can use custom loops and stuff if you really absolutely have to. But make sure there's no sessions, and tf.collections is gone. Variable collections and all that stuff is gone now. The graphs and all that stuff is, collections, they're all gone. So you don't have to, if you have any of that stuff in your code, throw it out, and just make sure that it's still going to work with like a brute force throwing out. Otherwise, you might have to do a couple little, polishes here and there, but it should work pretty well. It takes a little bit of work, that's assuming you have to go to step 2 and beyond. But maybe step 1 and you're done and you're like, sweet, it works, and it's awesome. But if you have to do a little bit of work, it's not so bad to get it to be idiomatic TensorFlow 2.0. But it results in fewer lines of code, and we all know code it leads to technical debt. So the more code you have, the more technical debt you're going to build, the more code you have other people to read. Remember, code is much more often read than written. So therefore, the less you have for others to read and be more concise, the better people are going to be able to understand your code and be able to build off of it. There's increased clarity and simplicity. Like I said, there's not 5 ways to do the exact same function now. It's one thing, and there's easier debugging because it's all eager and everything. It's very nice. No more having to figure out, like, you know, do a print statement on a tensor and like, oh yeah, all I see is the shape, the name, and the type. And then I have to run it in a session, and oh, I didn't pass the right things to the session. I have to basically create test data and use a debugger and all that craziness. Now it all just works with Eager. It's very nice. So, like I said, there's an automatic conversion script. If you click that link, it'll take you right to there. It'll do an initial pass at upgrading all your code to 2.0. It's very nice. It won't make the code idiomatic, so like the style and everything of 2.0 won't be there, but it will make it runnable. It'll use a lot of these tf.compat.v1 endpoints to place things that don't exist anymore. Oh yeah, placeholders. They don't exist anymore. Cool, huh? Variable scopes, gone like the wind. I'll show you on the next couple of slides. A lot of that stuff's gone now, so it'll have there for like historical sake, it'll be there as a tf.compat.v1, but we don't need that anymore, so it's gone. And if you want to do everything the 2.0 style, then you're just going to go through there using those steps 2 through 5 in the last slide and kind of just do a pass and just like, oh yeah, yep, you know, kill this, kill that, you know, change this to that, and that way it'll be ready to go. But the most of it, 99% of the stuff, that script will get. It's very nice. I think it would have been a huge failure on TensorFlow's part to not make that script because that's the biggest pain. That's why people are using COBOL and everything still in banking and stuff. And like back in physics, they're using Fortran and everything still because there's just so much code and there's no easy way to like convert everything to a more modern language that, you know, people just stay on the old stuff. Not good. So some of the top level behavioral changes. So if your code works in 2.0 using this compat v1 disable v2 behavior, so basically you're turning off any of the v2 stuff, there still might be some global behavioral changes you need to address. So major changes are eager execution stuff. So things that you specifically did not have using eager, like graph, like explicitly using graph stuff, that might still be there. Resource variables, tensor shapes, control flow stuff. All these things might still be there. Just do a pass through your code, you know, scroll down and look for any of these things. The great part is that script not only will convert, but the things it can't, well, it'll leave in the log. And you literally just go to that line and change whatever you gotta change. So therefore, you don't have to like be searching, you know, for a needle in a haystack. Just go to the line in the output of the script. It's all done. Very nice. Are you excited about that?
Yes, I am.
He's excited. I'm excited too. Anyways, so here's the eager execution now. So any code that uses tf.graph explicitly is going to fail. Okay, so you just want to wrap this code, you know, in a with statement here as default, and then it'll start working again. Pretty crazy, huh? What you could do if you really wanted, you could just get rid of all that tf graph stuff and then just put it into a function. It must be in a function to be able to use the @tf function decorator. But all you have, if you could do is cut and paste it into a function, you know, wrap it, def, you know, whatever, boom, it'll work. It'll still be a graph and it will work in 2.0. Okay. Resource variables. So you can do this too if you want to enable your resource variables. So some code that it may depend on non-deterministic behaviors by these resource variables. So these are locked while being written to, and to provide a more intuitive, you know, consistent experience. Okay, so it may change behavior in edge cases. It may create extra copies of variables and have higher memory usage. Some models already use really big, you know, a number of variables, a lot of parameters. So therefore, those are already huge. You don't want any more of those. Trust me. Like BERT and stuff uses, you know, megabytes and megabytes and megabytes, you know, gigabytes of variables. Don't do that. Okay, and this can be enabled by passing use resource equals false to the tf variable constructor. Which brings me to tf.get variable is gone. Now you just use tf variable, okay? The constructor for that. Tensor shapes as well. Okay, so TF 2.0 simplifies the behavior of tensor shapes. Instead of having a TF.shape, dot value, you can just say TF.shape and select the one you want. Okay, so these changes should be small, but it should make sense to fix them right away. So you can go to tensor shape right there and see examples of things you need to change. Basically, we just took a step out. So therefore, instead of having like a tensor returned, and that's why you have to do dot value, it's the value of the tensor. Now let's just do the shape and you get the exact thing right out there. So that'll return you an integer right there. TF.shape0 gives you the int, and then you're done. It's very nice if you want to do a dynamic shaping and everything. So I would suggest going through there and just checking things. Lastly, control flow. So the 2.0 control flow implementation has been simplified. So it's going to produce different graph representations. So if you were expecting a certain graph, it will be different now perhaps, right? Because of TF cons and a lot of those things have been changed a little bit. So, right, where it evaluated both branches of the condition tree and then would return the non-dead tensors back. That's kind of been changed, to control dependencies, all that stuff. It's been changed a little bit. So it's not like it's going to break anything. It's just going to give you a different graph. So if you were expecting like graph A, it's not going to be graph B, which does the same thing as graph A. It's just different. Okay, so you can just check all those things on how it connects things together. Okay, it's basically how it stitches your subgraphs together is basically the main thing. Okay, so that's that. Any questions on those high-level things? Before I show you some code examples, I did some side-by-side comparisons so you can see like, oh, here's prior to 2.0 and here's 2.0. But that's coming up. Any questions before that? Wonderful. All right. So if you did all that, oh, sweet.
Hey, Dan, I'm sorry. One quick question. TF trigger were also available in TF 1.0, right? We added that functionality in, I think, TF 1.7 or 1.8. How this thing is different in TF 2.0?
What do we add in 1.8, you said? I couldn't hear.
Eager execution.
Eager, yes. So eager execution was not on by default. You would have to do tf.enable eager execution, I think it was.
Yes.
And you'd have to like reset your Python session and all that funness and everything. And if you want to disable it, you have to like set that to, it'd be a big mess. Now eager is by default, and if you want graphs, you need to explicitly ask for graphs, mostly by using the TF function decorator.
Okay, cool. So we are saying that, okay, previously the things that we were doing with tf.eager, now we are doing with tf.graphs.
I'm saying eager is default. You don't have to do anything to do eager. Eager it's out of the box eager. If you want graphs, you have to do special stuff now. Whereas it was reversed before.
Exactly.
By default, it was graphs, and you had to do something special to make it eager. Right?
Perfect. Thank you so much. Yep.
Well, great. Good question. All right, so what you need to do is you want to replace any v1.session.run calls because we don't do sessions anymore. They are gone. They are like the way of the dinosaur. Goodbye. You also want to use Python objects to track variables and losses. This comes about with a variable scope being gone now. I'll show you. You want to upgrade your training loops. And you want to upgrade your data input pipelines, you want to migrate any of those compat v1 symbols, just find the version that is like from core now and get rid of all that compat stuff, right? We don't want any of that, garbage hanging around, right, as we get on. So every session.run call should be replaced by a Python function. Okay, so the feed dictionary and the placeholders, they become the function arguments, right? So remember, you actually do a feed dictionary, and you would feed a tensor into a placeholder, essentially, that had the same name, right? Do you remember that? And then you would do all that fun stuff. The fetches are your outputs, essentially. So it's saying, essentially, like, hey, in this graph, these are the things I want you to evaluate. And yes, it would build the dependency tree backwards from those things in the fetches list, and it would say, okay, well, these are my start points because those are my endpoints, and I got to run the graph now. Now it's just the return value. That's all it is. Return whatever you want, and boom, it works. During conversion for eager execution, it's going to allow easy debugging with standard Python tools like PDB and all that stuff. And if you absolutely must have it be a graph, like I said, at tf.function, boom, it works. It's a graph. It runs efficiently. It's going to optimize any bad code you have. So if you did like tf.add 20 times, it'll do one tf.add once, plus 20 or whatever, right? There's a guide here. It'll be in the slides I give to all you. So click the guide. It'll tell you all about autographing and how it converts things. Simple things like an if statement, instead of having like, tf.cond or tf.where, all that stuff's gone now. It's just Python. It's very nice. Note that TF function has a fixed return signature, and it always returns all the outputs. So if this causes performance problems, you might want to create two separate functions. So like one function returns A, one function returns B. In case you have an example of where you returned nothing or something else weird, if you want to just like optimize performance, then just have two separate functions, right? Doesn't matter. Remember, under the hood, all it was doing anyways was making a subgraph. So now all you're making is two subgraphs and connecting them together. It's no difference, but it might be more performant. Also, there's no need for our TF control dependencies or sim operations. So TF function, it handles the scope and all that, and the variable assignments and all that stuff, and the TF.asserts. So it's all executed automatically. I think you might remember from some of the stuff I showed before with control dependencies, I had to like wrap that around all these things because it wasn't in a function, and you had to do the variable assignment inside of the function and then return it with the dependency and all this craziness. Now, whatever happens in the function happens in the function. You don't have to worry about it anymore. About, oh no, it doesn't work, didn't connect correctly. It connects now. So therefore, everything's automatically taken care of. It's very nice. Next is Python objects. So all name-based variable tracking is strongly discouraged in 2.0. So instead, you should use Python objects to track these variables. Okay, so you're going to use tf.variable instead of getVariable. GetVariable's gone. And every variable scope you used to use should now be converted to a Python object itself. So essentially, the layer, like you'll see here, the layer, the model, the module, this will be the thing that contains the variables. So within that layer, that will hold all the variables. Rather than having an additional variable scope, and inside the variable scope, it might have some variables, it might have some layers, and then I connect them and all that. Now, you have a layer, and the layer is your variable container now. Or a model is your higher level variable container. Or the module is your really high level variable container. Okay? So that's how we do it now. That layer object holds your variables rather than having a explicit scope. Does that make sense to everybody? For those who use variable scopes, I used to use them. I like them, but this is even easier now. Just give it to the layer. Wonderful. If you need to aggregate lists of variables like how we used to, remember tf.graph.getCollection, tf.graphKeys.variables. Remember that? For those of you who don't, you would do something like this when you did batch normalization. Remember? Fun stuff. Now, all you do is you literally will do dot variables or dot trainable variables attributes from your layer or model objects. So much nicer and cleaner looking instead of that nasty long line right there. Okay, so these layer and model classes, they implement several other properties that remove the need for global collections. They contain the losses. They contain metrics. All of that stuff is contained in there now. You don't have like separate metrics and losses and all that stuff floating all around. It's all contained within that layer or model class. It's all in there as an attribute. So nice. Big pain in the butt having to pass all that crap all around before. Now it's very nice and all contained within whatever classes you have, right? Whether they're pre-built classes or classes of your own, right? If you want to make a custom layer or a custom model, add whatever you want in there, and there it is, okay? I'll show you an example a little later. You want to upgrade your training loops, so you'll use the highest level API that works for your use case. So pretty high level is using keras.model.fit. I would recommend that. Less can go wrong. When you make your own, more can go wrong, right? It's a high-level function. It manages basically all the low-level details. For example, it automatically collects the regularization losses, All you do is set training equals a true argument and all that stuff when you call your model. So that way it knows whether you're doing evaluation or training or prediction, all that stuff. It's very nice. You don't have to have this estimator, train spec, eval spec, all that crazy stuff. It's just boom. It works with .fit. It's very nice. We'll show some examples in a little bit. Upgrade your input pipelines. So like I said, TF data, we've been using TF data before, but TF data has a lot more cool tricks now with experimental stuff. It's very easy, efficient. You'll actually be returning this to .fit. So instead of returning like a input function that was like wrapped inside of this other function inside, now you just return a data set object and boom, it'll work. It's very nice. The data set object, right, it has your features inside, it has your labels inside, it has whatever else you have inside your data set object, right? It's a tuple of things. You just pass that .fit data set, how many epochs you want to train this thing for, boom, it goes. You can iterate over things if you want to split data set into features and labels, whatever. You can do a tuple expansion on it if you want. Right? You can do whatever you want. It's very nice. I would recommend this if I were you. Also, you just go through the compat symbols, right? Like those ugly, who wants that? So just go through and whatever the script didn't get, just kill. So it would do the obvious things like v1.argmax. It would just convert it, automatically to tf.argmax. But if there's anything left over, just go through there. Like I said, it's all in the log if there's anything. And then just go there and go to line 418 and figure out, oh, it didn't do whatever dot stack. So tf.stack or whatever it didn't do for some reason, just change it, right? Just to make it look clean and pretty, right? Low-level variables and operator execution. So some examples of this. So if you are like me, you like it in low level, then you might have a little more work to do, but not much. So these are some examples, variable scopes, like for reusing. So like for instance, I did in what was it? It was a encoder decoder, a conditional decoder. I used a DNN inside of it, but I wanted to use the same DNN outside of the decoder. So I had to reuse in the variable scope. Reuse equals tf.auto reuse. Now that's gone. You don't need it anymore, so just change it. Collections are all gone. So all that will be there. Placeholders are gone. Session.run's gone. Initializing variables manually, if you did that for some reason, gone. So how do you do this? Here's an example. Look at how easy it is. Look at how small the code is now, right? So we have our placeholders. Don't need this anymore. We have a function called forward here, and inside the function we have a variable scope called map_mul, and we do a get variable for W, get a variable for B, right? Then we would call that. We would define our regularization losses with its own scope here. So you see we have what scope am I doing regularization on? I want to only do regularization on this map_mul scope, right? Because there could be other variables that I don't want to regularize for my loss. So therefore I wouldn't do that. And then to top it off, I have to call in a session, I have to initialize my global variables, and then I have to run it in my session, giving it my fetches, giving it my feed dictionary, all that fun stuff. Going on to the right, what we do here, we literally just define the variables, have a function, I wrap it in a tf.function for a graph functionality, I call Keras regularizer, and I say, regularize W, please. Done. Cool, huh? It's very, very little that you need to do now. It's much more straightforward. There's less to keep track of, less boilerplate, less of having to keep track of what scope is what. Now it all works out of the box. It's very nice. So that way you can get all this thing working for you without having to do any craziness. So as you saw, what we did, the variables are local Python objects now. The forward functions, it still defines the calculation, but now all that weird scoping and all that stuff's gone. The session.run call is replaced with just calling the function. It's cool, just call the function now. The TF function decorator was there for performance, so in case I wanted to be really fast, put a TF function, but I didn't have to do that, okay? That's the main point. I did not actually need that. I just wanted it there because I wanted to be maybe faster, Okay? The regularizations are all calculated manually without referring to any global collection. There's no like, oh, well, it was this scope way over here, right? It's not. It just says, here's the variable name, the Python object, boom, regularize it, please. And then no sessions and placeholders, as you saw, right, on the right. Very, very simple. Do it. Any questions on that? I got to create a model to figure out what the exact amount of time to wait for a question is, where you can't see anybody, I've done about 6 of these now or something. All right, so moving on. What if you have models that use TF.layers? I have tons of them, tons and tons of them. Half of our ASL content uses TF.layers. So all you need to do, and it's the ones that relied on variable scope, which I have plenty of those, you can do the following. It's much, much nicer. So all you do now is you'll see, instead of having a variable scope with reuse and all that stuff, I don't need any of that now. I just throw it out. Everything pretty much stays the same. Instead of using tf.layers, I use tf.keras.layers. Really no difference, right? I did it here in a sequential model using the sequential keras API. I could have done functional if I wanted, but I didn't because it's pretty straightforward. This is a feed-forward network. There is no branching, no craziness, no side inputs. It's boom, straight down. So why not put it in sequential? And you'll see what I do here. I just call the model. I give it my training data, my test data, and it works. There's nothing fancy I had to do here. No variable scopes. Very nice. Very little change here. It's a really easy one, right? Also notice the regularizer. I just use tf.keras regularizers.l2. Much better than that ugly contrib one, right? Instead of having tf.nn.relu or tf.relu or tf.other ways to do a relu, I just do relu. Quote relu. Done. Nice, huh? Moving on. So you see simple stack of layers. It was basically a one-to-one between TensorFlow.layers and keras.layers. Okay. Almost everything else stayed the same. I got rid of some of the arguments because I don't need them now because it's all layer-based in the object, so we don't need any of that stuff going back and forth with x. You see on the left here we have x equals x equals x equals x equals. We don't need that now because it's all contained within that sequential model object. So simplification, you should do it, right? The more simple your code is, the easier it'll be. All right. Also note that I got rid of the contrib, and there were no longer any rights to the collections. We just said do the loss and be done with it. No special get regularization loss garbage like here. If you have mixed variables and layers, so it's not just layers. Now you have variables by themselves and layers. All you do is make your own layer, right? You make a custom layer like over here. Now you might be like jumping out of your chair like, oh my God, the code on the right is bigger than the code on the left. What am I going to do? No, it's not that big of a deal. It's just a custom layer. So you just create a class that inherits from the base layer object. You initialize it, to get the super from it. And then you just build, a function called build. How do I build my layer? Oh, I want to do, define my shape and my, I want for this weight here, W, my type, the initializer, regularizer. Do I want it trainable or not? Maybe. And there you go. Then all you do is you create a function, in this case called call. I'm going to wrap it turn it into a graph with TF function there, just because I like graphs and I want it to be fast. I give it my inputs and whether or not I'm training. And then basically, if training, do this. If not training, do that. That's all I do. And it uses my custom layer object. That's all it does. And you can see what I do here. When I'm actually using the sequential API, I start off with my custom layer, right? So it's just W, right? So all it is W. Essentially, it's a weight. And then I connect that weight with a convolutional layer, and then a pooling layer, then a flat end, and all that. So there you go. And the cool thing is it's totally reusable. I can use that custom layer anywhere I want, create different instances of it. As you can see, the size right here is 28 by 28 by 1. I could have done it on any other different kind of thing. It would have made a float 32 initialized to 1, regularized with 0.02 trainable layer. That's it. So it's an object. Just make as many as you want and give the parameters of the things you want to be different. And that's it. Cool, huh? You think it's cool? Does anyone on the phone think it's cool? Please. I think they do. I think they're just
cool.
Oh, good, excellent. There you go. I was going to say that they were just in shock of how cool it was. They were just stunned, speechless. Yeah, it's nice. The more you can make code reusable, the better, right? It's a custom layer. Make whatever you want now with it. All right. Yeah, as you saw, I subclassed the Keras model and layer and ran it in both the graph, or you can do eager mode, right? So when you're not running it as a graph, just get rid of the tf function and boom, yay, eager. Right? You wrap the call. Don't forget to accept the training argument to the call. So sometimes it's a tensor, sometimes it might be a Boolean argument. It could be anything. So just make sure that whatever you have coming in comes into your function call, right? So remember, you have call self inputs and training equals. So you can pass tensors, you can pass lists, you can pass dictionaries, whatever you want to pass, and just make sure whatever you are going to use comes in. Okay? Simple as that, and it'll build the graph for you with autograph. Okay, it's very nice. Man, I already kind of talked about all this. I don't want to go through it again. So, can you still not give up 1.x? Are you clinging to the past? Do you need to see a therapist? Right? Sorry for all the jokes. It is still possible to run 1.x code if you absolutely must, okay? Unmodified, except for contrib, because remember, contrib is gone, okay, in 10.0. It's 2 lines of code. You're going to import tensorflow.compat.v1 as tf, and then you'll just do tf.disable v2 behavior. Yay! Everything that's not 2.0, all the TPO 2.0 stuff is gone, and then the 1.x stuff will run, right? However, it does not let you take advantage of all the improvements made in 2.0. Okay? Essentially, you've done like a pip install of 1.x is essentially what you've done. So therefore, you can't use any 2.0 only stuff, any of the new stuff that will come out over the next months and years, but all your 1.x stuff will just work like it always has, right? But you want to do all the package management and all that stuff. It'll just do it with 2 lines of code. So you don't have to do the pip install and worry about your container and all that stuff. It just works like this. Right? So what you also want to do is simplify input functions. It's a little small. You can zoom into it when you get the slides. But essentially, like over here, I don't need to decode CSV anymore and blah, blah, blah. I can just go over here and I use tf.data.experimental.make CSV dataset. Yay! 1 line with some parameters and it's done. I have a CSV dataset. You just map it like you do over here, shuffle like over here, prefetch, all that stuff. And then the difference is when you call your input functions now, over here we had our whole little eval, our train spec and our eval spec. We would pass that to our train and evaluate loop and the estimator, all that fun stuff. Now you don't need any of that. You just literally call the function, and then I have my train data set, my eval data set, and I pass it to fit. Done. Yay. Also, Keras training loops, okay? So instead of having this big mess over here, now it looks a little long because I include the model here as well. This is the model code. We do a .compile. It puts your optimizer, what your loss function is, what your metrics are. And then boom, it makes your model. And then you do .fit. You give it your training data, and then it does it. And then .evaluate, and it does it, and it's done. None of this craziness. And this is all imperative, right? It's not building some graph object, it's actually running the model, right? And you can access it with the attributes and all that stuff instead of having to reach into the crevices of your estimator and try to pull stuff out, right? It's so much easier using a Keras training instead. How to train on GCP? Are we using G-Cloud? So 2.0 was just released, 2-3 weeks ago? October 1st, right? So it's been 3 weeks basically. So very little time has passed. All the other product teams at Google are trying to catch up to make sure that it works with everything. So we've done some work and we still have a little bit more work to do, so bear with us. But there are workarounds right now to do it, which we will show you. So what you can do is you can be like me and you can use cloud AI platform notebooks, which are really, really nice. And they come with 2.0 pre-built in. So as you can see here, you click the hamburger, you go to AI platform, you click on notebooks, you click on new instance, you click on TensorFlow 2.0. If you want to customize it if you want. I just went with the straight one, and boom, it makes it. And 2.0 and all required libraries are in that container, and it works out of the box. It's very nice. However, if you want to train on AI platform, there are a couple little things. The great news for you is it is copy and paste. It is great. So all you gotta do is gotta use a Docker container image. That's it. Okay. The first thing to do is create a Docker file. So you create this Docker file here, and all you do is point to this right here, your trainer module. So if you're using the AI platform for using G-Cloud, you were already creating your trainer module. Remember, model.py, trainer, shoot, what's it now? Brain. Model.py and all those things, right? And then what you'll do there is you'll have that in a trainer folder, and you'll just point to that, and then boom, it'll create you your Docker file, and then you'll deploy the Docker file essentially, right? And that'll be that. So then once you've done that, you just create a shell script to export this Docker image and all the other stuff, your project, your repo, all that stuff. Notice here's the container I just created in the last one, baby weight training container. And there we go. That'll all happen within this file here. Next one's a real hard one. Call bash and call that file I just made. Push Docker, boom. It'll do it. It'll do a whole bunch of installs, load packages, all that stuff. Takes a couple minutes, but then it's done. And as long as you don't change your model code or anything like that, yay. Just change the parameters on the command line and you're good to go. Then you'll see here's your classic G-Cloud command job. The only difference here is I am passing in an image to my master rather than it being whatever the base image is, where you'd usually do like -- runtime equals, whatever TF version you're using, and then you'd have like a -- Python version equals, 3.5 or whatever. Now instead I would say, here's my custom image. It'll do that. It'll load your container and it'll do all that stuff. Very, very soon you won't have to do that at all. Instead you'll just say -- runtime version equals 2.0 -- Python version equals 3.5 or whatever, right? And that's it. Any questions? I am almost on time for once. Any questions? There's a lot that's happened, but hopefully it wasn't like that scary. It's like literally only a few things changed, and it actually just made things easier. There's nothing like harder that came. It's all just easier stuff. Yeah, please ask questions. Now is your chance to talk to the Google expert. Do you have anything?
No.
He has nothing. All right, going once, going twice. Sold. All right, well, thank you very much for all attending. I will once again add this recording to our spreadsheet of all the past recordings. I'll put the link to the slides in there. I'll put a link to any code snippets. The ASL, we're doing ASL 2.0 right now, where all of the old ASL using TensorFlow 1.0 is now being converted to 2.0. We are almost done for that, so the cohorts coming up will get the first taste of that. Our first pass, I'd say. Nothing's perfect, but it'll be good. You can see access to that too. We're going to update the repo, the training data analyst repo, to all the 2.0 stuff. We've already done some of it right now, but more is to come. So thank you very much. We'll have more webinars coming up very soon. So please vote or give suggestions on anything you want, and then we'll do it. Right? Your wishes are our command. So we want to make you happy and be able to use all this cool stuff. And I think these webinars are a great way to show it. Thank you very much.
All right.
Thank you.
Thank you.
And the recording.